For decades, we believed the universe was expanding ever faster, its galaxies racing away from each other in a relentless cosmic sprint. This idea shaped our understanding of the cosmos, painting a picture of a universe destined to grow colder and emptier with every passing eon. The further we looked, the more evidence seemed to support this vision. A universe stretching into infinity, with its stars and galaxies fading into the darkness. For years, scientists predicted a lonely, frozen future where all matter would drift apart, and the cosmos would end in a cold, dark silence. This view, built on Nobel-winning discoveries and decades of careful observation, seemed unshakable, etched into the very foundation of modern cosmology. The discovery of the universe's accelerating expansion was hailed as one of the greatest scientific achievements of our time, but today, a groundbreaking study from South Korea is shaking the very core of this belief. Their research suggests that the universe's expansion may actually be slowing down, not speeding up as we once thought. This bold claim is forcing scientists to reconsider everything we thought we knew about the cosmos. If these findings are confirmed, it could mean that gravity, the force that binds stars and galaxies together, might eventually overpower dark energy, the mysterious force thought to be driving the universe apart. Instead of drifting endlessly, the cosmos could one day reverse course, leading to a spectacular cosmic collapse. The force we thought was pushing everything apart, dark energy, may not be as constant or as powerful as we believed. Its true nature remains one of the greatest mysteries in science, and now it seems we may have misunderstood it entirely. This revelation forces us to rewrite the universe's story, transforming our vision from endless expansion to the possibility of a dramatic reversal, a universe that could one day contract, pulling everything back together in a cosmic finale. Around the world, scientists are now racing to verify these astonishing claims. Teams are re-examining old data, designing new experiments and debating what this could mean for the fate of the cosmos. The idea of a collapsing universe, once dismissed, is suddenly at the forefront of scientific debate. The fate of everything, galaxies, stars, even the atoms that make up our bodies, may be far different than we ever imagined. The very fabric of reality could be woven into a story with a far more dramatic ending. Once dismissed theories are back in the spotlight, and scientists are revisiting old ideas with fresh eyes. This could mark the beginning of a new era of discovery, where the universe's fate is once again an open question. The universe's final act may be more thrilling and mysterious than we ever thought, reminding us that in science, even our most cherished beliefs can be overturned by a single, extraordinary discovery. To truly grasp what's at stake for our universe, let's revisit the two most dramatic theories for how everything might end: the Big Rip and the Big Crunch. These aren't just abstract ideas, they represent the ultimate destinies of all matter, energy, and even the fabric of space and time itself. For decades, scientists have debated which of these fates is more likely, and each scenario paints a radically different picture of the cosmos's final moments. The Big Rip is a vision of cosmic destruction driven by dark energy. In this scenario, dark energy doesn't just keep pushing galaxies apart, it grows stronger over time, accelerating the expansion of the universe to unimaginable speeds. Galaxies are torn from each other, then stars are ripped from their galaxies, and eventually even planets, molecules, and atoms themselves are shredded apart. The universe becomes a place of utter isolation where every structure is destroyed by relentless expansion. In the final stages of the Big Rip, nothing remains but scattered, lonely particles drifting through an endless, empty void. The universe would be cold, dark, and silent. A cosmic graveyard where even the smallest building blocks of matter are separated forever. It's a haunting vision of total dissolution, where the very fabric of reality is stretched to its breaking point. The Big Crunch, by contrast, offers a very different ending. Instead of expansion accelerating forever, this theory imagines that the universe's growth will eventually slow down, stop, and then reverse. Gravity, the force that once struggled to hold galaxies together, would become dominant again, pulling everything back inward. Over billions of years, galaxies would begin to approach each other, colliding and merging in spectacular cosmic events. The universe would become denser and hotter as everything is drawn closer together, reversing the process that began with the Big Bang. Eventually, all matter and energy would collapse into a single, incredibly dense and hot point, a fiery singularity. This would be the ultimate cosmic implosion, erasing all structure and returning the universe to a state of unimaginable heat and density. Some theories even suggest that this could trigger a new Big Bang, starting the cycle of creation and destruction all over again. In this view, on the end of one universe could be the birth of another, a cosmic rebirth from the ashes of the old. The Big Crunch is a dramatic, fiery finale, a universe ending not in cold emptiness, but in a final blazing convergence of all that ever existed. It's a vision of cosmic renewal, as much as destruction. Which of these fates will be ours? The answer depends on the true nature of dark energy, the mysterious force that drives the universe's expansion. Scientists are racing to understand its properties, because it holds the key to our ultimate destiny. Now, a groundbreaking new study suggests the Big Crunch may not be as unlikely as we once thought. The possibility of a cosmic reversal is back on the table, challenging decades of assumptions. The universe's destiny is once again up for debate, and the stakes couldn't be higher. As we peer deeper into the cosmos, we're not just searching for answers about distant galaxies, we're searching for the fate of everything that ever was and ever will be. The idea of endless expansion rests on one of the greatest mysteries in modern science: dark energy. For decades, astronomers believed the universe's growth was slowing down, but a hidden force was quietly rewriting the story of the cosmos. In 1998, scientists made a groundbreaking discovery. By observing distant supernovas, exploding stars that serve as cosmic mile markers, they noticed these supernovas were dimmer than expected. This meant they were farther away than predicted, revealing that the universe's expansion wasn't just continuing, it was speeding up. This was a revelation that shook the foundations of cosmology. This finding was completely unexpected. According to everything we knew, gravity, the force that pulls matter together, should have been slowing the expansion, not letting it run wild. To explain this cosmic acceleration, scientists proposed the existence of dark energy, a mysterious force that makes up about 70% of the universe. It's invisible, undetectable by ordinary means, but its effects are everywhere, shaping the fate of everything we see. The leading explanation is that dark energy is a cosmological constant, an unchanging property woven into the very fabric of space itself. Even in the emptiest voids, this energy persists, quietly driving galaxies apart. As the universe expands, more space means more dark energy, which in turn accelerates expansion even further. This runaway process could eventually tear apart galaxies, stars, and even atoms, a scenario known as the Big Rip. This idea has become the cornerstone of modern cosmology, guiding research and shaping our understanding of the universe's ultimate fate. But all of this depends on a crucial assumption: that dark energy is truly constant, never changing over time or space. If this isn't true, everything we think we know could unravel. Now, a new study from South Korea is challenging this idea. Their research suggests that our measurements of dark energy, and the assumptions behind them, might be flawed, opening the door to new possibilities. If dark energy isn't constant, the universe's destiny could be far stranger than we ever imagined. It might slow down, collapse, or evolve in ways we can barely comprehend. With every new discovery, the universe reminds us how much we have yet to learn. The mystery of dark energy is far from solved, and the answers may change everything. The shakeup comes from Professor Young-Wook Lee's team at Yonsei University. Instead of new telescopes, they re-examined the original evidence for dark energy, type Ia supernovas. These standard candles were thought to have a fixed brightness, making them perfect for measuring cosmic distances. But Lee's team suspected the brightness might depend on the age of the stars that explode. They analyzed 300 host galaxies, studying the color and age of their stars. Their key insight: older galaxies produce brighter supernovas, while younger ones yield dimmer explosions. This subtle difference had been overlooked for decades. By factoring in the age of the host galaxy, they uncovered a hidden pattern in the data. This new approach led to a startling conclusion about the universe's expansion. The results were revolutionary. Supernova brightness is tied to the age of its host galaxy. Older galaxies yield brighter supernovas, younger ones, dimmer. This undermines the standard candle assumption and throws previous distance calculations into doubt. The dimmer supernovas in the distant universe may not be farther away, they may just be less bright. When Lee's team corrected for this, the evidence for accelerating expansion vanished. Instead, the data now suggests the universe's expansion is slowing down. The era of acceleration may already be over. We may be witnessing the first signs of cosmic deceleration, a crucial step toward a possible big crunch. This finding forces a complete re-evaluation of the universe's fate. The cosmic story is being rewritten in real time. The universe's future is more uncertain and more fascinating than ever. If the universe's expansion is slowing, dark energy can't be constant. Instead, it must be weakening, a dynamic force, not a fixed one. This evolving dark energy, called quintessence, could have driven early acceleration, but is now fading. As dark energy weakens, gravity regains its influence. The Big Rip becomes unlikely. A cosmic reversal is possible. If this trend continues, expansion will halt, and contraction will begin. We may be living at the universe's turning point, the moment before the fall. The engine of expansion is sputtering and gravity is poised to take control. The universe's fate hangs in the balance. One study isn't enough to overturn decades of consensus, but Lee's findings align with other major datasets, including results from the Dark Energy Spectroscopic Instrument, DESI. DESI's massive galaxy map hints that dark energy may not be constant, supporting the new model. The evolving dark energy model also resolves some inconsistencies in the cosmic microwave background. More data is coming, and Lee's team is planning new tests to confirm their results. The scientific community is watching closely. This could be a true revolution in cosmology. The universe's secrets are starting to come into focus. The idea of a big crunch is dramatic, but it's not imminent. These cosmic timescales are almost unimaginable. Billions of years in the future, the universe's turnaround point may be nearly 20 billion years away. Earth and the Sun will be long gone before any collapse begins. The fate of the cosmos is a scientific question, not a cause for immediate concern. What matters is how this research demonstrates science's power to question and evolve. Even fundamental truths can be overturned by new evidence. Our understanding of the universe is always a work in progress. The journey of discovery continues, with new mysteries always on the horizon. The debate over the universe's fate is just beginning anew. The Yonsei study challenges the old model, and new observatories like the Vera C. Rubin Observatory will soon provide a flood of data. Thousands of new supernovas will be discovered, allowing scientists to test these ideas with unprecedented precision. The next few years could settle the question, is dark energy constant, or does it change over time? The answer will reshape our understanding of reality itself. As we stand on the brink of discovery, the universe proves more complex and surprising than we ever imagined. The quest for knowledge continues. The cosmos still holds many secrets, waiting to be revealed.